So in our example 1, we are now given the periodic function f of t is equal to pi minus t when t is in between negative pi and 0. So we have to sketch the graph for 3 periods, and when you are told 3 periods, you sketch the 1 period, then the other periods you can get them by having a repetition of what is going on. So part 2, determine the Fourier series. Part 3, from the Fourier series, by letting t to be equal to 0, you show that pi squared all over 8 is equal to summation n starting from 1 to infinity, 1 all over 2n minus 1 squared. So you do that letting, and then you get your result. So let's start in our solution by sketching the graph for 3 periods. So when you have a function which only carries up to t power 1, then your function is made up by portions of straight lines. If here it is pi minus t, or pi plus t, or t only, provided you are not going to t squared or t cubed, you are dealing with the straight portions of straight line. But when you have t squared in your expression, then you must know you are dealing with a curve. But here we are just dealing with what? Dealing with the straight lines. So in a straight line, what do you need? You only need the end points of your straight line. Then with your ruler, you will make up the straight line. So we start end points of our straight line. This is first portion. When t is minus pi here, when you insert minus pi here, it will be pi minus negative pi. So f of t will now be 2 pi. So we say now, when t is equal to negative pi, f of t will be equal to 2 pi. When t is equal to 0, we are now taking this end. We started from here, now we are going to another end, 0. When t is 0, f of t will be equal to pi. So when t again is equal to 0, when t is equal to 0, we input 0 here, f of t will be equal to what? Pi. And when t is equal to pi, our f of t will be equal to 2 pi. So these are the endpoints that we need to sketch. And after sketching, we input them. After sketching, then we are going to use our graph for other purposes. So we have something like this. Here can be pi, negative 2 pi, negative 2 pi, negative 3 pi. Then we have here pi, we have 2 pi, we have 3 pi, we can have here pi, and we can have there 2 pi. This is the graph of f of t, and that is our t axis. Now this is point negative pi, 2 pi. So when we have negative pi, we are going up to positive 2 pi, we are there, that is the point. When t is 0, f of t is pi. So 0.0 pi, which is this point, that is 0.0 pi. When t is 0, f of t is pi. So 0.0 pi, which is the same point. And when t is pi, f of t is 2 pi. So we are going upwards, we are there. So that is it. So we join those points with the straight line, straight line, straight line. And after joining those points with straight line, that is only for one period, one period. Now you are told, you are supposed to do it for 2 periods. And then you say, hii kitu huwa inaanza ikiwa juu. So imeanza ikiwa juu, imeteramuka, alafu inamaliza ikienda hivyo. Now from this, we have another period we can now insert here, which is now that. So that is our function for 3 periods. Now that graph we are also going to use it now when we reach part 3 of this question. Because if you don't have your graph in place, there will be no way you will answer part 3 of this question. Now from there, you can now answer part 2. Part 2. Now when we check our function, because our function started from here up to there, these are just other periods. When you check from here up to there, is that function even or is it odd? That function is what? It is symmetrical about the vertical axis. So it is an even function. So after knowing it is even, we say in our part 2, the graph is symmetrical. The graph is symmetrical. Is symmetrical about the vertical axis. About the vertical axis. Hence, about the vertical axis, hence f of t is an even function. An even function. Therefore, our Bn will be equal to 0. This implies our f of t, how we'll write its Fourier series representation, will be a naught all over 2 plus summation n starting from 1 to infinity, n starting from 1 to infinity, an cos n pi t all over what? L. But 2L of ours, the full period was 2 pi. So our L value is equals to what? Pi. So finally, when we'll be writing our Fourier series, this will be a naught all over 2 plus summation n starting from 1 to infinity, an cos nt. Because if L is pi, this pi will cancel that other pi. So we'll remain with the cos what? Cos nt. Now let's start by getting the Fourier series coefficients. Let's start by getting determining the value of a naught. A naught. A naught now will be equal to, because this is a special function, our a naught will now be 2 all over L. We do it from 0 to L. Then f of t cos n pi t all over L. The what? Dt. which will be equal to 2 all over pi. We are doing it from 0 to pi. So when you want to check your function of t between 0 and pi, what is the name of our function of t? It is what? Pi plus t. So that's what you write, pi plus t. Then multiplying cause what? Nt, because L is pi. Then we have here dt. Don't worry to what happens on the other interval, because this is a special function. Whatever we are doing there, why we are saying it is 2 times, it contains the other portion. So you simply do 2 all over pi, 0 to pi, pi plus t equals nt dt will give us the full result. If you are doing it from a general perspective, we would have used 1 over L. Then we say it would have been from minus L to L. Then we get what? We get the answer. But by doing this, we are just trying now to shorten our working, because this is a special function. With our evaluation, this is pi plus t, this is cos nt. If you differentiate this, you don't get pi plus t, or you don't even get t. If you differentiate pi plus t, you don't get what? You don't get cos nt. Do you get that? So those are 2 different functions which are not related to each other. If they are not related to each other, then we can only clear by integration by parts. It's a question. This is an. That is an. That is an. Not a naught.
Where can we use the function of t to pi plus t, not pi minus?
Huh?
But if we use the function of t, pi plus t, not pi minus t.
Go back to our function. That's why I did not erase this, so that you can be able to see. Between 0 and pi, what is the name of our function? That one. Is that okay? Yeah. That's why we are not using this. And I explained why we are not using this. This one is now consumed into this other one. Yeah. This is an, not a naught. So we use our integration by part. We let u to be equal to what? We let u to be equal to pi plus t. And we let our dv to be equal to cos nt. From your integration by parts formula, if you can remember, we know the integral of u dv is equal to uv minus the integral of v du. So that's what we're going to use. So 2 all over pi is here. Then we have a bracket. Our du will be what? Let's write it before we insert it. Du will be equal to dt, and our v will be equal to 1 all over n sine nt. Meaning you integrate this. Du, you differentiate this. When you differentiate this with respect to t, you get 1. Du dt is 1. So du is equal to d what? Dt. So uv we have 1 all over n into pi plus what? T into sine nt. Then we have limit from 0 to pi minus the integral from 0 to pi minus the integral from 0 to pi v du. So it is 1 all over n sine nt. Then we have the dt. We close the bracket. Now when we insert this value here, Where there is t, you input pi. It will be sine n pi, n pi. Sine n pi is normally equal to 0. When we insert 0 here, it will be sine 0. And sine 0 is also 0. So the whole thing comfortably approaches 0. So we are now integrating. When you integrate sine nt, the integral of a sine is a negative cos. A negative will see this negative and it will multiply. We will get now a positive answer. This constant will divide by that particular coefficient of t. So this one will now go to n squared. So it will be 1 all over n squared cos what? Nt. Cos nt. And then we input our limits from 0 to pi. Which gives us what? 2 all over pi. This 1 over n squared, we can take it out. It will not change because we are only inserting the values of what? T. When you input here pi, it will be cos what? This will be cos n pi. Where there is t, we will put pi, we will get cos n pi. Minus, when inserting lower limit. When you input t here, you input 0 where there is t, it will be cos 0, which is what? 1. But we agreed that cos n pi can be written as negative 1 per what? N minus 1 now. Now, when you check that expression, we've gotten our value of an. But when you check that expression, something is going to happen here. When n is 1, for example, this one will continue being negative 1. When it is 3, it will continue being negative 1. When it is 5, it will continue being negative 1. So, for all the numbers, this one will be minus 1, which is minus what? 2. So, it will be minus 2. So we say this one when n is odd, an will be equal to what? An will now be minus 2 times 2 minus 4 all over pi n squared. All over pi n squared. Now, when n is even, so when n is 7, what will happen? This will be negative 1 power, an even number will be positive 1. Negative 1 power 2, 1. Negative 1 power 4, 1. Negative 1 power 6, also 1. 1 minus 1, 0. So our an will be equal to 0. That means our an will only be defined for odd values. Then we go for a0 because we have not established the value of a0. A0 now will be 2 all over L. We integrate from 0 to L, f of t dy dt, which is 2 all over pi. We are integrating from 0 to pi. Our f of t between 0 and pi is pi plus what? T. Then we have this one as d dt. which will be 2 all over pi. We have pi t. When you integrate pi is a constant, you get pi t. When you integrate t, you get what? T squared all over 2. Then we have 0 to pi. Two over pi. Let's input this so that we get that answer. So this will be pi squared. This is 2 all over pi. This will be pi squared plus pi squared all over 2, which will be 3 pi squared all over what? 2. The lower limit will bring all the zeros. So the answer here now will be this will be equal to, now that pi will cancel that pi, 2 will cancel 2, so the answer is 3 pi. So document that one. So we can proceed. So our function of t is equal to a naught all over 2 plus summation n starting from 1 to infinity. Then we have an cos nt. That is according to our simplification, because this is a function of period 2 pi. Now our a naught, we pick it and we divide by 2. So it will be 3 pi all over what? 2. Now we say summation n starting from 1 to infinity. Our an value was only defined for odd values, and it was minus 4 all over pi n squared. But n must now be odd. Now we don't want to talk. We just want to insert something that when we input our values will just bring out odd values. So where there is n now, we insert 2n minus 1 to represent the odd values. Now this is cos. The n also must now be what? An odd value. 2n minus 1 multiplying what? T. You replace where there is n, you put 2n minus 1. This one we only do when we are dealing with odd values. Now we can simplify this and say this is 3 pi all over 2. Minus 4 over pi is a constant and can be allowed to pass our operator, where our operator is the summation sign. So this will be minus 4 all over pi summation n starting from 1 to infinity. Then we have 1 all over, this one was squared. Our n was squared, Yeah. So 1 all over 2n minus 1, which is now squared. Now this one multiplying cos 2n minus 1 multiplying t. That is now the Fourier series representation. Fourier series representation. Now we can write some few terms for the series so that we can be able to see it. And even if you reach here, that is now the correct Fourier series. This is just a way you've written it in short, but you can also write it in full. So sometimes even if you leave it there, you get your full marks. So f of t will now be equal to 3 pi all over 2. Then we say minus 4 all over pi Then we open a bracket. We would like to have summation. When n is 1, this one will be 1 all over 1 squared, isn't it so? Because 2 times 1 is 2. 2 minus 1, 1. So we have a scenario, 1 all over 1 squared cos 1t, because n is now 1. So 2 times 1 minus 1, you get 1t. When n is 2, this one will turn into 3. So it will be 1 all over 3 squared cos 3t. When n is 3, it will be 1 all over 5 squared cos 5t. Now plus others, we stop. So when we simplify, it is 3 pi all over 2 minus 4 all over pi into cos t plus 1 all over 9 plus 1 all over 25 cos 5t plus others. That is now our function of t. So we are through with part 2 of our question. Now we go to part 3. You are told by letting t to be equal to 0. Show that something is happening. So we go back to our graph. From our graph, we are saying f of 0, you insert 0 here. And because what you are showing has got still summation sign, you go back to expression of function of t with the summation sign in it. Because you go back there. So this is our f of t, remember? So where there is t, we have inserted 0 is equal to what? 3 pi all over 2 minus 4 all over pi summation n starting from 1 to infinity. Then we have 1 all over 2n minus 1, which is square, which is square. That's what we are having. Because cos 0 will be what? Cos 0 is equal to what? 1. When t is 0, this will be cos 0, which is what? 1. Now we organize this formula so that we leave this one on that side. So we are organizing what is our f of 0 from graph. What is the value of f of t when t is equal to 0? Read it from our graph. The value of t, with the value of f of t when t is equal to 0. It is pi. So f of 0 is pi, is equal to 3 pi all over 2 minus 4 all over pi. Summation n starting from 1 to infinity. 1 all over 2n minus 1. Square. Now we take this one, bring this way. So it will be pi minus 3 pi all over what? 2. Is equal to minus 4 all over pi. Summation n starting from 1 to infinity. 1 all over 2n minus 1, which is square. This one will give us negative pi all over what? Over 2. Is equal to minus 4 all over pi. Summation n starting from 1 to infinity. 1 all over 2n minus 1, which is square. Now we move this one away. So we are going to multiply both sides by pi all over negative 4. So that when this one is cleared from here, so that we have this summation sign have a coefficient of 1. So this will be equal to minus pi all over 2 times pi all over negative what? 4. This is what will be equal to summation n starting from 1 to infinity. 1 all over 2n minus 1, which is square? Square. This one gives us now pi squared all over 8. N starting from 1 to infinity. 1 all over 2n minus 1, which is square? Square. And then we say hence shown. So we are through with that question. You can document